Welcome back, everyone. Today, we're delving into the intricate world of particle physics, exploring the mysteries of the groundbreaking Large Hadron Collider. Hey, science enthusiasts and curious minds. You're in for a treat. In this video, we're unwrapping the story behind the Large Hadron Collider, its discoveries, and the unexpected twists that have physicists on the edge of their seats. Don't forget to hit subscribe and ring the notification bell for more mind-expanding content. Let's dive in. Physicists worldwide anticipated the activation of the Large Hadron Collider, a game-changer in understanding the universe. Constructed by CERN, this colossal machine began operations in 2008 after years of meticulous construction and fine-tuning. Over the years, it played a crucial role in unraveling mysteries, but recent developments have sparked concerns among scientists. What is the Mandela effect, and why are scientists at CERN concerned about it? Notable figures like Stephen Hawking, Dr. Carlo Rovelli, and even President Obama expressed their worries about potential catastrophic events linked to the Large Hadron Collider. Could the LHC alter the fabric of space and time, causing unexpected changes in our universe? A 27-kilometer ring of magnets and structures, the LHC is the world's largest and most powerful particle accelerator. Operational since 2008, it aims to explore fundamental particles, including the elusive Higgs boson. Travel with particles at nearly the speed of light, witness collisions, and delve into the complex energy levels and revolutionary discoveries. Delving into the connection between the Higgs boson and the universe's fate unveils a captivating exploration into the very fabric of existence. The discovery of the Higgs boson in 2012, often colloquially referred to as the God particle, marked a pivotal moment in the quest to unravel the mysteries of mass, stability, and the fundamental forces that govern our cosmos. The Higgs boson is a subatomic particle that plays a central role in the standard model of particle physics. It is intricately linked to the concept of mass, offering a mechanism known as the Higgs mechanism. This mechanism suggests that particles gain mass by interacting with an invisible field pervading the universe, the Higgs field. Unraveling the secrets of the Higgs boson provides insight into why particles have mass, a fundamental property that influences the behavior of matter and shapes the structure of the universe. Connection to the Big Bang. Scientists are actively exploring the role of the Higgs boson in the early moments of the universe, particularly during the epoch of the Big Bang. The Higgs field, proposed to exist throughout space, may have undergone dynamic changes in its structure during the universe's rapid expansion. Understanding how the Higgs field behaved in these extreme conditions contributes to our comprehension of the initial moments of creation and the subsequent evolution of the cosmos. The Higgs boson is also implicated in discussions surrounding vacuum energy, a concept tied to the idea that even seemingly empty space possesses energy. The vacuum energy associated with the Higgs field could have far-reaching consequences for the stability and fate of the universe. However, this idea introduces a challenge known as the cosmological constant problem, a discrepancy between predicted and observed vacuum energy. Scientists are actively researching whether the Higgs field and its associated energy contribute to the mysterious dark energy that propels the universe's accelerated expansion. Shaping the forces in our universe? One intriguing hypothesis proposes that the Higgs field might be a fundamental force shaping other forces in the universe. As scientists delve deeper into the intricacies of particle interactions and the underlying structure of the cosmos, they contemplate whether the Higgs field plays a role in influencing the behavior of other forces, such as gravity and electromagnetism. This line of inquiry opens avenues to re-evaluate our understanding of the fundamental forces that govern the universe. In summary, the Higgs boson serves as a key to unlock the secrets of mass, stability, and the forces shaping our universe. Scientists are on a quest to decipher its role in the early universe, its connection to vacuum energy, and its potential influence on the fundamental forces at play. The exploration of the Higgs field not only expands our understanding of the cosmos but also poses profound questions about the fate and nature of the universe itself. In exploring the impact of the Large Hadron Collider, LHC, on technology and innovation, we uncover a fascinating intersection between theoretical physics and practical advancements that go beyond the realms of fundamental particle research. The LHC serves as a unique laboratory for scientists to investigate strong forces, delve into the properties of hadrons, and unravel the mysteries of the Higgs boson. Understanding these fundamental components of the universe not only contributes to our comprehension of the cosmos, but also paves the way for transformative applications in technology. The technologies developed to construct and operate the LHC have far-reaching implications. The precision required for particle detection and the immense data processing capabilities necessitated the development of cutting-edge technologies in fields such as materials science, electronics, and computing. These advancements have subsequently found applications in various industries, from healthcare to telecommunications. The collaborative effort involved in building and operating the LHC has fostered an environment of interdisciplinary research and problem-solving. Scientists working on the LHC bring together expertise from diverse fields, leading to innovative breakthroughs that extend beyond particle physics. These breakthroughs have the potential to spark new ideas and solutions in areas such as engineering, materials development, and information technology. The LHC's colossal energy consumption has prompted the development of energy-efficient technologies and sustainable practices. As scientists grapple with the challenge of powering such a massive particle accelerator, advancements in energy management and conservation have emerged. These developments are crucial in a world increasingly focused on sustainable and eco-friendly solutions. The sheer volume of data generated by the LHC experiments necessitates advanced computing infrastructure and algorithms. The demand for efficient data storage, processing, and analysis has driven breakthroughs in high-performance computing and data analytics. These innovations extend beyond particle physics, impacting fields like artificial intelligence and big data analytics. The LHC's contributions to the refinement of the standard model of particle physics have had a profound impact on scientific progress. Confirming the existence of the Higgs boson in 2012 was a monumental achievement that validated the theoretical framework describing the fundamental particles and forces in the universe. This validation not only enhances our understanding of the cosmos but also provides a solid foundation for future theoretical and experimental endeavors. In essence, the Large Hadron Collider stands as a testament to the symbiotic relationship between pure scientific inquiry and technological innovation. As physicists explore the fundamental nature of our universe, the technologies and methodologies developed in this pursuit reverberate across various disciplines, fostering a ripple effect of progress and innovation that extends far beyond the boundaries of particle physics. That concludes our journey through the enigmatic world of the Large Hadron Collider. If you enjoyed this exploration of particle physics and cosmic mysteries, give us a thumbs up and share your thoughts in the comments below. Don't forget to click the link on your screen for more fascinating videos from our channel. Until next time, stay curious, stay informed, and we'll see you in the next video. Thanks for watching.